Alright, in this video we're going to talk about fractional equations and things with fractional coefficients, okay? Now we're going to have to be careful because sometimes this will blend together with the simplifying, adding and subtracting rational expressions. Okay, so to solve some equations that have fractional coefficients, there's two ways you can do it. The first way you can look at it is you take a look at your fractional coefficient, 1/5, and you can turn it into x over 5 because you can put the variable in the denominator. It's like 1 times x, or in the numerator, I should say. Numerator. It's numerator, huh? Spelled right. Okay, and you can turn it to x over 5 plus 2 equals 6. Well, you should be able to solve this. Subtract 2 from both sides. You get x over 5 equals 4. And then multiply through by 5, and you get x equals 20. It works a lot of times, but sometimes we're going to have variables in the bottom, and that's where we're going to get a problem, okay? To do method 2 is we're going to clear the fraction of its denominators, okay, by finding something we can multiply through by. That thing we're going to multiply through by is the LCD. So if I have 1/5 x plus 2 equals 6, these are over 1, and I got to say to myself, hey, what's the LCD of this all? Oh, it's 5. Well, if you multiply all of these terms by 5, so a 5 here, a 5 here, and a 5 here, these 5 should cancel, and you have x plus 2 times 5, which is 10, equals 6 times 5, which is 30. You subtract 10, and you get x equals 20. Okay. So you can see that's a little easier as long as you can find the LCD. It's going to be more prevalent when we have things that are fractional equation where there's variables in the denominator. Okay, so in the denominator, like this, okay? We have this equation here, we have another one here. You notice how there's variables in both of these. Don't solve the one on the right here. It kind of doesn't come out to be very nice. All right, so we're going to multiply again by the LCD and see what happens. And if we take a look at this one, 12 times 12, y and 4. The LCD is 12y. So it's 12y times 1 over y plus 12y times 1 over y. Oops, this is a 12 here. Equals 1/4 times 12y. If you do it right, there should be no denominators left. Cancel, cancel, y. Y's cancel, plus 12. This cancels, I'm left with 3 equals 3y. And then you just got to solve. Subtract y. 12 equals 2y. Divide by 2. Y equals 6. Okay? If you check this, it'll work. Notice how we don't have any undefined, because we're going to later run into that problem. You just got to make sure of it. All right? So the one over here, 2z, z and 2, LCD is 2z. Watch the way you write your z's. Multiply everything by 2z. 2z and 2z. Okay? The 2 z's cancel there. I'm left with 3. The z's cancel there. I'm left with just plus 2 equals. The 2 cancels there. I'm left with just z. Nice and easy. Z equals 5. Okay? No problems there. Right? When you solve, though, we're multiplying an equation by the LC. Sometimes when we have variables, we need to factor the bottom in the equation to find the LCD. Okay, it's easier to find the LCD usually in a factor form. When you do this, we may not create an equivalent equation, two equations that reduce to the same value. What's going to happen? You might multiply through, and you're going to lose your denominators. Okay, and if you do that, you might actually be multiplying by something that's undefined. Okay, you can't really do that. So we need to check to make sure we don't have any undefineds. Okay, so we may get solutions, but they may not work. So we have 3 questions here. If I take a look at this one, I'm going to factor the second one, and you can see it's x times x minus 3. That equals 5 over x minus 3. If we take a look, well, what's my LCD? They all have an x minus 3. I better multiply them by, they're missing an x, so I'm going to multiply them by x times x minus 3. X minus 3. X minus 3. And then x minus 3. Okay, cancel out. Again, I should make sure that we have no common, or we should have no fractions left. So I'm left with x squared on this one. The x minus 3 cancels there. Oh, the x cancels there. Plus 6. That cancels that. I'm left with 5x. Well, quadratic, get everything equal to 0. Subtract 5x from both sides. And then this factors. X. If we try this, 3 and 2 minus minus. X equals 3. Remember, we set them equal to 0. Add 2. We get x equals 3 and x equals 2. If we look at this, you're going to notice, plug in 3. 3 over 3 minus 0 is 3 over 0. Ah! Okay, undefined. We can't use this one. This is a reject. This makes it undefined. Okay, so be aware of that. So our only answer is just x equals 2. We should check it to make sure, but we should be good. Over here we have another one, okay? One of the people's likes to do is cross multiply. Well, you can cross multiply. You're going to see it's a little harder if you cross multiply it, but you can do it. You just got to watch your factoring. If you factor the right one, you get y times y minus 2. Well, my LCD is y times y minus 2. And y times y minus 2. Cancel, 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 cancel. I'm left with 4 on this side. The y's cancel. I have to multiply that out. Gonna have to FOIL it. Y squared minus 4y plus 4. Remember, first outer and last. Yeah, well, you get the gist of it. Alright, subtract 4, because you want to get it equal to 0. Y squared minus 4y equals 0. Factor out your y. Y minus 4 equals 0. Set each of those equal to 0. Y equals 0, and y minus 4 equals 0. Y equals 4. Check to make sure you don't get undefined. Uh-oh, plugging in 0. You get a problem. If you plug in 4, you get 4 minus 2 over 4, which is 2 over 4, which is 1/2. 4 squared is 16 minus 8, which is 8. 4 over 8 is 1/2 as well. Reject. My final answer is just y equals 4. Last one. All right. Make sure you multiply everything through in order to do it. So over here, I'm going to multiply by the LCD. You can put this over 1. And I'm going to multiply it by w minus 3. W minus 3 times 2 over w minus 3 plus 4 times w minus 3. That's what I'm adding in, multiplying in. Equals 2 over w minus 3. And we're going to put our w minus 3 in there. Okay, if done right, no denominators. That's just 2 plus 4w minus 12. Watch your signs. Equals 2. Combine those, that's 4w minus 10 equals 2. Add 10. 4w equals 12. Divide by 4. W equals 3. Alright, check. Uh-oh, 3 minus 3 is 2 over 0. That's bad. In this case, they have no solution. It is the empty set, or that. Okay? Should make sense, though. These two are the same. If you add 4 to something and you don't add it to the other, it isn't going to stay equal, ever. Think about it. No number ever does that. Add 4 to it, to the same number. You don't get the same number back, do you? Change it, okay? So one of the things we just have to be careful about is look at the difference between an expression and an equation. Okay, that's the biggest. First things first, when we look at these, one's going to have different directions. One says simplify, perform the operations. The other says solve for x. Both of them are going to still have pretty similar processes. You're going to factor both of them. However, you are going to multiply through by the LCD just like this to get an equation solved. When you do it for this, you want to make the bottoms the same so that you can combine the tops, okay? This one's going to have no fraction. This one, you're keeping the fractions, okay? In the end, you're going to combine the tops, and you're going to get a rational expression. You're going to have variables in it. This one's going to have a variable equal to, okay? Be careful not to confuse the two, okay? You do start with the same thing. It's just equations you multiply through. This one here, you're going to make it so your denominators match up, so you're going to multiply pieces in. The ones that are expressions are going to be big fractions at the end. This is going to be an x equal or an a equal into this case. So be careful of them, and good luck to you, and we're almost there. Take care.